500 light-years away, a twin Earth orbits a star like our sun. This distant world could harbor life.
One of the greatest questions that humans have asked is, are we alone in the universe?
Closer to home, there are moons with ice caves and hidden oceans. What secrets do they hold?
Ideas that were science fiction a year ago are reality now.
To unlock the mysteries of these deep space habitats, we will strip them to their cores. Dive into their hidden oceans and peel open their crusts to reveal the secrets of alien worlds. Mankind is on a hunt for alien worlds. High-powered telescopes scour the night sky. Probes scout out exotic moons and planets, while scientists explore the most extreme environments on Earth.
All of our evolution, we've wanted to know what's over the next hill, what's over the ocean, what's off the planet.
As scientists investigate alien habitats, they're uncovering mysteries on our own planet.
And what we see is that every niche on Earth where life can possibly exist, it's there. Now, question is the Earth the only place in the universe where there's life?
The quest for alien worlds is an exploration into the unknown. Scientists scour the depths of our solar system, where frozen moons spew ice into space. And harbor hidden oceans. Space probes pierce thick clouds, shrouding strange worlds, to reveal hostile, icy landscapes and liquid methane lakes. Astronomers search for Earth-like planets deep in the Milky Way. And listen for messages from alien civilizations, echoing through the cosmos.
The galaxy is huge. It just crushes our ability to grasp scale into dust.
The universe may be vast, but alien worlds could exist on our doorstep. In our own solar system, a strange icy world lurks in the mists of Saturn's outer rings. Enceladus, a tiny frozen moon the size of Great Britain. Its icy surface reflects sunlight like a mirror. The ice stretches over 100 kilometers deep. Down towards the moon's rocky core. Is it possible that life exists in the darkness beneath the ice? Scientists explore extreme places on Earth to help solve this mystery. Enceladus has a perfect parallel. The Don Edwards Nature Refuge, a dried-out salt marsh. The 2-inch thick salt crust here completely blocks out the sun, keeping the ground below in eternal darkness.
Most of the other worlds we're interested in our solar system, it's the subsurface where we're likely to find any life at all.
NASA scientist Chris McKay hunts for life that lives in the dark. Methanogens, tiny microbes that thrive underground. They were among the first life forms to appear on Earth over 3.5 billion years ago. Perfect examples of how life adapts and evolves.
On Earth, anywhere where we find methanogens, I'm interested. They don't like oxygen. They eat hydrogen. They don't have any use of sunlight at all. They live in the deep subsurface. They are my favorite candidates for micro-astronauts on another world.
Chris searches for samples of methanogens under the salt crust.
The salt is providing a protection and also a barrier. Here, and the top is just the salt, the white layer. Then the green layer. These are organisms that use sunlight, photosynthetic. Then the pinkish layer. These are organisms that really like salt. Then below them is the black stuff. In there are methane-producing organisms.
These methanogens swarm through this black mud. 1 million of them would fit on a pinhead.
This will be a little tiny model for a huge world, Enceladus. And by understanding this in detail, we'll develop insights that we can then generalize with.
The more scientists study Enceladus, the more surprising it becomes. At 200 degrees Celsius below freezing, all the water on this moon should be frozen solid. But it's not. Tiger stripes on the South Pole reveal something incredible occurring beneath the surface. These gigantic cracks in the ice lead down to a huge saltwater ocean. The briny liquid is laden with hydrogen, the perfect methanogen food. They could thrive here. As Enceladus orbits Saturn, the planet's massive gravity stretches the icy canyons apart. The ocean water escapes, shooting out of the tiger stripes in huge icy plumes. March 2012. Scientists piloted the Cassini satellite through the plumes of Enceladus. The satellite's instruments detected traces of organic molecules, the building blocks of life. Chris McKay is now planning a mission to bring a sample of the plume back to Earth. He hopes it'll be full of methanogens.
I think the most exciting thing about Enceladus, there's material coming out right into space. We don't have to drill, we don't have to dig, we don't have to search. We just fly right through and grab it up and bring it back home. It's wonderful. It's like there's a big sign, free samples, take one.
These icy eruptions throw material away from this alien world into orbit around its parent planet, Saturn. The water spraying out of the cracks freezes instantly and shoots hundreds of kilometers into space. Some of the ice escapes the moon's low gravity and drifts away to form the icy outer ring of Saturn. If there's life on Enceladus, it might be able to escape and, from Saturn, spread through the galaxy.
Everywhere on the Earth, evolution has found some sort of life to take hold. And that's probably true everywhere else in the universe.
Life is very creative and prolific and robust. It seems to occupy every little nook and cranny on Earth. Every rock we lift, we find life in places where we didn't expect there would be life.
Deep in the ocean, near volcanic vents, there have been found life forms that derive their energy from the materials coming up from the volcanic vents. And if we can see this kind of ingenuity on our own planet, then when you start thinking about alien worlds, who knows what clever mechanism nature has worked out to produce life.
As scientists look deeper into space, the possibilities for new life-bearing worlds keep growing.
As we look out at the universe, we recognize that it's the same laws of physics, it's the same chemistry, and it's the same composition of stuff everywhere. That chances are life is everywhere throughout the universe.
Alien beings could live and thrive in the most surprising places. Could an ice cavern hidden inside a moon be home to a new kind of life? Around the world, giant optical and radio telescopes scan deep space in search of alien worlds. Scientists are looking for signs of a precious liquid that turns barren rocks into thriving ecosystems. Water.
Life on Earth is very diverse. Not all life forms require oxygen. Not all life forms even require sunlight. It looks like every single organism on the Earth requires liquid water.
Water is abundant in our outer solar system, but almost all of it is frozen in the form of ice covering comets and moons. These frozen landscapes endure perpetual winters, with temperatures 10 times colder than a winter's day on the North Pole. But life may still hide among the ice crystals.
Just because a planet is very different from the Earth, it could be a lot warmer, it could be a lot colder, that does not guarantee that there's no life there. In fact, if you think about our own planet, everywhere on the planet, evolution has found some sort of niche for life to exist.
Life on Earth has found a way to fight back against the cold. In Washington's North Cascade Mountains, snow and ice cover the ground all year round.
This is my backyard. And what we have here in Washington's North Cascades is a really deep snowpack. I take Harvey as much as I can. Harvey loves the snow.
Professor Robin Codner searches for life that can defy the odds in a frozen world.
Since life on Earth is a product of a couple of billion years of evolution, it's impossible to know exactly what life in other places in the solar system or beyond would look like. So all we can do is go to places on Earth where there's similar conditions and see what life is doing there.
Robin hunts for life that could take hold on the icy moons of our solar system. Europa is one of 67 moons that orbit Jupiter. Surface temperatures can drop to minus 220 degrees Celsius. The moon is covered in rock-hard ice, but strange marks running across the surface betray activity hidden deep below. Beneath the hard outer crust, a more fluid layer of softer ice. Slushy currents push the soft ice along with life-giving minerals around the moon, creating a fertile environment that life could exploit. On Mount Baker, Robin has found a type of life that could also exist on Europa.
I see some right around here. Oh, wow. Pink snow, so there's some snow algae living here.
This algae is called Chlamydomonas nivalis, or watermelon snow. Unlike plants that need soil to thrive, the algae can grow on naked crystals of frozen water. They produce a pink substance that protects them from intense sunlight.
It's a little bit pinker just under the surface here. Ooh, this is good. And it's getting pinker as I dig down. And so the conditions for the algae are even better in the subsurface.
The Mount Baker algae can survive winter temperatures of minus 25 degrees Celsius. Europa's surface remains 20 times colder year-round. Europa, however, hides another potential habitat. 3 kilometers below the surface, an icy cavern filled with a pocket of water larger than the Great Lakes. Salt in the water acts like antifreeze. 30 kilometers below the surface, the source of the water. The ice opens out into a hidden ocean. It holds twice as much water as all of Earth's seas and is 10 times deeper. Is it possible that life already exists on Earth that could survive on Europa?
Just sampling here can help us understand why they're happy here, and then that gives us some range of possibilities that we might search for outside of this planet.
The algae on Mount Baker have adapted to survive in a frozen world.
This group can be found in hot spring environments and deep hydrothermal vent environments and snow environments in dry Antarctic deserts, and they're pretty adaptable. Oh, snow algae, I love you.
Robin's algae are the ultimate survivors on Earth. Back at her lab, Robin can see how well these microorganisms are coping with the hostile conditions.
I'm just hoping to have a look at all the different cells under the scope so I can estimate how many different kinds of algae I can see. Oh, cool, there's like a biofilm here. So this clump is where the microbial community are. There's thousands of cells kind of all caught up in this matrix. This sample is just teeming with life.
But life on Europa may be completely different.
Life on Earth evolved around water, and we know that if you throw a condition at life on Earth, that life has figured out how to exploit that. But that doesn't mean life elsewhere follows the same rules, and so that's what's really exciting about looking for life elsewhere.
Extreme environments could encourage extreme forms of life to evolve. Orbiting a small red star 16 light-years from our sun is the planet GJ832c, an Earth-like world where conditions are always changing. The planet's orbit is so tight, it takes just 36 days to complete. Alien life must adapt quickly as winter spreads across the planet once every month. The more we search for potential alien worlds, the more we find. One moon orbiting Saturn hides behind a thick orange atmosphere. Its surface had never been seen until a recent mission sent a probe down through the clouds.
We got our first look at the surface of Titan, and what a shock, what an amazing sight.
Hidden below its alien atmosphere lies a world unlike any other in the solar system. This impenetrable orange cloud hides possibly the most alien world we have in our solar system. Titan, the largest moon of Saturn. Bigger than Mercury, it looks nothing like our own planet from space. But up close, Titan appears strangely Earth-like.
Titan's atmosphere is mostly nitrogen, kind of an eerie similarity. It makes us feel like Titan is our twin planet out there.
In 2005, scientists landed the Huygens probe on the surface of the moon. The images it beamed back showed totally unexpected geographical features. The probe revealed a secret beneath Titan's thick orange atmosphere. Something exceedingly rare in our solar system. A network of lakes. But these lakes did not contain water. At 200 degrees Celsius below zero, water would freeze. Instead, these were seas of methane.
Methane takes the place of water here on Earth. This evaporates up and goes into Titan's atmosphere, rains out in other places, and then forms streams and rivers, which then flow into the lakes and start the cycle over again.
Lake Powell in Utah. The landscape here mirrors the lakes and valleys on Titan. Ralph Lorenz is developing space probes to explore Titan's lakes.
This is such a good place to do our testing because the landscape here has a very branchy shape to the shoreline. That's the same as on Titan. Of all the worlds in the solar system, Titan is the one, apart from the Earth, that an unprotected human would survive the longest. You could hold your breath for a minute, and then after a while you'd freeze to death. But you'd last longer than anywhere else.
Titan's methane seas could hold the key to life on this alien world. To find out more about them, Ralph is developing a sonar device. It'll scan Titan's seabed to build up a detailed map.
Life as we know it requires liquid water. On Titan, it might be that the processes of life can occur in a non-water liquid in the seas of methane. We want to understand the three-dimensional structure of the seas on Titan. We can do that with sonar, just like we do on Earth. So this is an oscilloscope to let us look at the signal. This bad boy, a real sonar transducer we would send to Titan.
Ralph's instruments must be extremely tough, small, and light to survive on board a space probe.
The sonar sends out a pulse of sound. And from the time it takes for the echo to come back, we can determine how deep the sea is.
Space scientists like Ralph are discovering that Titan's geology is very similar to Earth's, with one huge difference. The Huygens probe has discovered that what looks like a rocky landscape is completely made of ice. Deep inside, scientists found the engine that creates Titan's features. Huge pockets of ammonia-rich liquid water under enormous pressure. Like magma on Earth, this supercool fluid can break through cracks in the moon's crust and erupt in huge volcanoes, creating streams of icy lava. These ice volcanoes could have helped create Titan's mountains, valleys, and seas.
Titan has an amazingly complicated landscape, and we're just learning whether it was really made in the same way Earth's was.
Ralph's next probe to Titan will carry instruments that will analyze the chemistry of the methane seas. However, his sonar device will have to operate autonomously, floating away from the main probe as it scans the seabed.
Well, that's working as well as predicted. The next step would be to integrate the sensor with a freely floating capsule and see how to build a profile as we drift across the sea.
Titan is similar to the Earth, but really different. You know, it's based on methane and it's very cold and the atmosphere is different. And yet we think that conditions could be okay there for life to arise.
Of all the alien worlds that orbit our sun, Titan is one of the most complex and intriguing. And one day it could become the most habitable place in our solar system. In 5 billion years, our sun will expand into a red giant and incinerate Earth. But Titan will get less UV radiation from the dying sun. The dense, smoggy atmosphere will clear and allow sunlight through. The surface temperatures will rise, and the ice will melt. The moon will become a primordial Earth for hundreds of millions of years. Plenty of time for life to emerge. Our solar system has revealed extraordinary worlds with hidden alien habitats. If these wonders exist so close to home, what mysteries might be orbiting our neighboring stars?
I look up in the sky and no longer do I see points of light that are stars. I see solar systems.
Pick a star, it more than likely has planets orbiting it.
One of these distant worlds could be just like Earth.
5, 4.
In 2009,
2, engine start. 0.
NASA launched the $600 million Kepler Space Telescope to speed up the search.
And liftoff.
Before Kepler, we didn't know what fraction of stars had planets.
Kepler has the biggest telescope mirror we've ever sent beyond Earth's orbit. Its mission? To hunt for planets that orbit distant stars.
We didn't know whether there was enough debris left from star formation that would accumulate into planets.
So far, Kepler has discovered almost 1,000 planets.
Now we know, statistically, many, maybe even most of the stars in our galaxy that you see when you look up at night are orbited by planets.
21 of the planets scientists found orbit their stars at the right distance to have a climate similar to Earth, and maybe oceans teeming with life. Astronomers have found one solar system that looks extremely promising. Kepler 186 is a star 500 light-years away from Earth. Scientists spotted 5 planets in its orbit. 4 of these are too hot to have liquid water on their surface. The 5th is right in the sweet spot for life. It could be Earth's twin. But space telescopes cannot take pictures of this planet. The glare from its star is too bright. Pasadena, California. Engineers here are designing a unique spacecraft to see these hidden alien worlds.
The scientists I work with are like Columbus, and I'm building his boat.
Mark Thompson heads up NASA's Starshade project. Flown into space, this huge sail unfurls like a giant umbrella and blocks out the light from the star.
It's similar to putting your hand up against the sky so that we can see around the sun. All of the discoveries made so far have been indirect measurements. This allows us to see those planets directly.
Today is a big day for Mark's team. The very first time they test a Starshade prototype.
Okay.
To create the perfect shadow, Starshade must fold out its foil petals into an exact circle.
Christine, want to hit the switch? Okay, motor's on. As it pulls free of the little clips, it will jerk here and there. Things that are unexpected happen. What was that? Right. We have a problem. It was crooked. That was it. Whoa. Okay. Motor speed coordination problem. Okay. That's it. It deployed. We had some problems. One spoke broke, and we had a snag in the line. And this is why we do these deployments. And we'll improve those features for the next one and be ready to go.
This prototype is a scale model. The real Starshade will be twice as big. It'll fly 37,000 kilometers away from its parent telescope to shade the target star. Planets that orbit distant stars will finally become visible. Starshade could uncover the mysteries of some of the galaxy's strangest planets. Like Gliese 163c. It hugs a cool red dwarf star, which means temperatures could be right for life. But the star's massive gravity stops Gliese spinning, which could do very strange things to the climate, scorching one side into a barren desert, while the other side is frozen solid in icy, eternal darkness. Just a narrow, habitable strip, battered by violent storms, survives between the extremes. The prospect of finding life on another planet drives the Starshade team.
All of our planning centers around about a 10-year time frame. The next big step is to put a giant blanket on it that makes it opaque so that distant starlight doesn't come through it. And we have a lot of work ahead of ourselves to get there. But today we had a successful test and we're one step closer to finding life on other planets.
Not every new world that Starshade finds will support alien life. Planets that fall too close to their star become hostile worlds. 40 light-years from Earth, planet 55 Cancri E almost touches a sun-like star. Heat radiating off the star pushes temperatures on the planet to over 3,000 degrees. A layer of graphite covers the entire surface. And beneath this rocky blanket, extreme pressure has turned carbon into diamond. But life could not exist there. Scientists are hunting for planets similar to Earth, with running water on their surface. But it's not just water that makes Earth special. It supports life with a secret weapon in its atmosphere. Stars in the Milky Way provide light and warmth that could support life on the planets that orbit them. But stars are also hostile, just like our sun.
The sun is the most violent, dramatic thing in our solar system.
The sun is a giant nuclear reactor. It belches streams of radiation towards Earth. A constant barrage of charged particles called the solar wind.
They're actually high-energy particles, and when they hit organic compounds, it actually breaks up the molecules. They could actually break up our DNA, cause damage, mutations.
The reason why life on Earth can survive this deadly onslaught hides 2,900 kilometers under the surface. The Earth's core is a molten ball of metal, nearly twice as big as the Moon. Immense pressure deep inside it forms a second core that is solid. As the two metal Goliaths grind past each other, they generate a huge magnetic field that seeps through the Earth and out into space. This gigantic force field engulfs our planet and shields us from deadly solar radiation. Without Earth's magnetic field, life would be impossible.
The Space Science Lab is perched here on top of a hill overlooking the San Francisco Bay.
Brian Walsh uses a network of 5 satellites called Themis to investigate Earth's magnetic field.
We're looking at some of the downlinks with the Themis spacecraft. We only have a very small window each orbit when we're able to communicate with the spacecraft.
The Themis satellites race through the very upper layer of the atmosphere. They orbit Earth every 23 hours. They have 4 25-meter-long antennae that allow Brian's team to measure how Earth's magnetic field reacts to blasts from the sun.
The typical length of one of these communication windows is about 50 minutes. And we'll be able to communicate with this dish here.
The team has to download the satellite's data and check on its health.
Right now, we're actually entering our window of communication with the Themis spacecraft.
We're relatively close to overhead from Berkeley Ground Station.
And this red shape around it is the area where we're able to communicate with the spacecraft.
We should get all the data.
It's fantastic, great.
For life to thrive on an alien world, it needs protection from its star. The same protection that we have on Earth.
For decades, we've thought that the Earth is kind of like the sun's punching bag, and that when an explosion happens on the surface of the sun, all this material just goes screaming through the solar system outward. It slams into the Earth and the Earth's magnetic field. And this is a bit concerning. We're kind of at the sun's whim. But very recently, we found some very interesting measurements with the Themis spacecraft that show that the Earth actually has some protection itself.
Earth doesn't just sit and wait for a solar punch. It has a preemptive weapon. As UV light hits the atmosphere, it creates a thin layer of charged gas. Earth's magnetic field squeezes this into a huge donut-shaped ring around the planet. When the sun whips up a solar storm, the highly charged particles in the ring start to shift. They gather into a massive tendril that reaches into space to meet the solar blast and slow the radiation.
So we actually can fight back a bit. It's quite exciting. Life in the form that we know it wouldn't be able to survive without a magnetic field protecting it from radiation.
Scientists think that Mars once had a life-supporting magnetic field as well. But 4 billion years ago, it disappeared.
Mars may have been Earth-like before Earth was Earth-like. But unfortunately, the atmosphere was eroded away by the solar wind. Climate change on a catastrophic global scale. I can't imagine any life could have survived such a huge event like that.
The sun also attacks other worlds in our solar system. But small moons like Europa rarely produce their own magnetic fields. So, on their own, they're not protected. However, in the case of Europa, something much bigger is on hand to help. Its parent planet, Jupiter, has a huge magnetic field that stretches 5 million kilometers from the planet. Its power rubs off on Europa and helps generate a small magnetic field around the moon. Earth has the key ingredients for life to flourish: a magnetic field, liquid water, and a breathable atmosphere. Could this magic combination exist on another planet in our galaxy? Could intelligent life have evolved there?
It used to be that when you'd go out at night and you'd look up in the sky, you had no idea if there were any planets out there orbiting those stars. Now we know many have multiple planets, their solar systems just like ours.
That chances are life is everywhere throughout the universe.
What are the odds that life exists outside of Earth? Stellar nurseries in our galaxy create new stars and alien worlds all the time. Our galaxy contains up to 400 billion stars, with untold numbers of planets. And there are 100 billion galaxies in the universe. With numbers so astronomically high, the odds suggest that life is out there. And it may even be intelligent.
There are probably many different variations. I think that reality is going to be much more fantastical than we can imagine.
An intelligent civilization might even send a signal back to Earth. This is the SETI Institute, a giant telescope array, listening for radio signals from alien worlds.
SETI, it's an acronym. It just stands for the Search for Extraterrestrial Intelligence, looking for the kind of life that's smart, intelligent, the way humans are.
Seth Shostak is the man in charge of the mission.
You know, when I was a kid, I was really interested in movies about aliens. It's the same sort of interest as dinosaurs.
A network of 42 small dishes work together to scan the heavens.
So wherever we point in the sky, we usually check out a few billion channels, because after all, ET never sent us an email saying, hey, this is what frequency you should listen at. Despite the fact that these things are only, what, 6 meters, maybe 20 feet across, they're incredibly sensitive. If you had a signal falling on the entire Earth of 1,000 millionth of a watt, 1 billionth of a watt, these guys could easily pick it up. And that's like a remote control for your car door on Mars. If our galaxy's not adequate for your life demands, you know, there are 100 billion other galaxies we can see, and they've all got a similar number of planets. So there's just literally an uncountable number of planets where life could have started up.
Despite over 50 years of silence, Seth remains confident that one day they will make contact.
But if we were to pick up a signal, it would become the most interesting science story probably of all time.
The discovery of life beyond the solar system will destroy our cosmic loneliness. You know, that feeling that we have when we look up into the sky and we feel very small? The knowledge of other living things out in the galaxy is going to have a major impact on how I view my own self and my relationship to other humans on this planet.
One of the things you really have to get your mind around is how connected we are to the Earth. Our chemistry, our biology matches this place. If we go to another planet, we might not be even able to eat the plants. So you have to realize just how much of an Earth creature you are, and use that to be humble when it comes to finding and interacting with life outside the Earth.
That's going to be a revolution in thinking for the humans who exist at that time. But that generation of people are going to be quickly replaced by a new generation of people for whom alien life is considered normal.
Our search for alien worlds takes us to the edge of our observable universe. We're discovering new Earth twins throughout our galaxy. And we're scouring strange moons in our own solar system. If there are alien life forms out there, it's just a matter of time before we find them. Unless they find us first.